afternoon, ladies and gentlemen. For this conference, I and two students in our team would like to present the result of our research that was a part of our community service activity, which is entitled Effect of Lignocellulosic Microorganism Isolated from the Peel of Cassava, Rice Straw and Sawdust for the Composting Process of Rice Straw. We are from Faculty of Agriculture, 11 Maret University. It is well known that application of compost can affect soil fertility and health, including increasing the availability of nutrients, improving soil physical quality, increasing the population density, diversity, total biomass, and metabolic activity of microorganisms, and eliminating soil pathogens. The quality of compost depends on the materials and technology used during the composting process. It is very important to produce compost in short period with high quality. However, the composting process will take a long time if only rely on indigenous decomposing microorganisms. On the other side, immature compost will harm the soil and plants. Ladies and gentlemen, one of the efforts to speed up the composting process and to improve the quality of the compost is by adding bioactivator. Based on this background, the present study is aimed to isolate lignocellulosic bacteria and fungi from several sources and to examine their capability as bioactivator in the composting process of rice straw. The next slide will be presented by Nadine. Nadine, please.
Thank you, Profita. The next slide is about materials and methods. The first step was the preparation of the sources of isolates. Sources of isolates of lignocellulosic microorganisms and general bacteria were obtained from the outer peels of cassava, inner peels and fines of cassava, dried rice straw, the mixture of mahogany and sangan sawdust with ratio 1:1, and 1-week-old rice straw compost. For the 1-week-old rice straw compost, the sample was taken from the center of the compost pile when the temperature reached about 60 degrees Celsius. The second step was the isolation of lignocellulosic bacteria and fungi from all the sources using a serial dilution of physiological saline solution. Then inoculated the sample by using spread plate method to 5 types of media that were carboxymethyl cellulose, lignolytic selection, Omeliansky, nutrient agar, and starch casein agar media. In addition, several small pieces of each sample were also inoculated directly to the respective media. After incubation for a week of room temperature, the population density and morphology colony were observed. Each type of colony in each medium was then purified and propagated in liquid culture from the same medium to be used as bioactivator. The next step was setup of rice straw compost and application of bioactivator. A total of 100 kg of dried rice straw was soaked in a basin of water and arranged into 2 piles. The first compost pile was a controlled treatment, while the second compost pile was treated with the addition of bioactivator. After 2 weeks of piling, the 2 compost piles were turned and moistened. At this first turning, the bioactivator was applied. The second turning was conducted on day 28, and then composting was terminated on day 60. During the composting process, we observed some variables of composting condition, and at the end of composting, we conducted analysis of chemical characteristics of compost product. The next slide will be explained by Kintavi.
Thanks to Nadine. Then I will continue for the result and discussion section. We have 3 points from result and discussion. In this table 1, we can see it's isolate from the mixture of mahogany and sangal sawdust in ratio of 1:1. We observe the colony morphology include the number of colonies, shape, elevation, surface, opacity, margin, and color from 5 sources of isolates. But in here, we only show the data of morphology colony from the mixture of mahogany and single sawdust. Then we continue for table 2. This table shows the colony diversity and population density of isolated lignocellulosic bacteria and fungi from sources of isolates. In total, there were 55 colony diversities found, consists of 25 types of bacteria colonies and 30 types of fungal colonies from 5 sources of isolates. The growth of isolates from the mixture of mahogany and single sawdust on Omeliansky media show the highest colony diversity and population density compared to other isolate sources. And for general bacteria and actinobacteria, isolated from 1 week old rhizome compost that grown on Na and Ca media shown similar types, but the population density was higher on Ca media. On the left side are some photos of lignocellulosic microorganism isolates. On the right side are some photos of pure culture of lignocellulosic microorganism. Next, in the table 3, we can see the composting condition. Data show that on day 7, the 2 compost pile reached the highest temperature, then on day 14, the temperature decreased. The bioactivator was applied to the pile of compost treatment on day 14. The effect of the addition of bioactivator was observed on day 21 until day 28. The temperature of the compost treatment increased while the temperature of the compost control decreased. This finding indicated that application of bioactivator resulted in the extension of thermophilic phase in the composting process. The thermophilic phase in the composting process is very important for the elimination of the harmful pathogens and viruses. The pattern of moisture content between the 2 compost piles were similar level during the whole period of composting. The initial pH of rhizome compost was the same, and after undergoing the composting process for 14 days, the pH increased sharply. The increase of pH in the composting can occur due to intensive ammonia production in the early weeks of the composition process. After day 21, both compost pile decreased in the pH toward neutral until the end of composting. This table 4, we can see characteristic of compost product. Compost with bioactivator indicated higher quality with CN ratio 15.2 and total nutrient 19.3% higher than compost control. The 2 compost product meet the quality standard for solid organic matter. For solid compost product according to the degree of the Agricultural Minister of Indonesia 2019. Next slide will be presented by Profita.
Thanks, Kintavi. Ladies and gentlemen, at this last slide, let me to conclude the results. The first point, isolation of lignocellulosic bacteria and fungi from the mixture of mahogany and single sawdust on Omeliansky media resulted in the highest colony diversity and population density compared to 3 other sources. Point 2, general bacteria and actinobacteria isolated from 1 week old rhizome compost that grown on Na and Ca media showed similar types, but the population density was higher on Ca media. Point 3, the rhizome compost product with bioactivator treatment indicated higher quality compared to the compost control. The last point, application of the mixed culture of all isolated lignocellulosic bacteria and fungi as bioactivator in the composting of rhizome resulted in the extension of the period of thermophilic phase, increasing the rate of composting and improving the quality of compost. That is all of our presentation. Thank you.